Imagine yourself driving a car on the highway. You are going the same speed as the car next to you. The car does not even look like it is moving, does it? If you could not see the trees flying past in the background, could you ever tell if the car was moving? If both your car and their car maintained the same constant velocity, you would never be able to tell if it was moving. Galileo wrote about this phenomenon back in 1632. Many contribute Einstein as the creator of relativity. However, it was Galileo that came up with the idea that Einstein would build his theory of relativity on almost 300 years later. Galilean relativity's main idea is that the laws of physics remain the same for all inertial frames. If an experiment is done in the car of a train moving with a constant velocity, the results would be the same as if the experiment was done off the train in a stationary lab. If the train was speeding up through acceleration or slowing down through deceleration, this would not hold true, as the velocity would not be constant. If it was going around curved tracks, the velocity would not be constant either, since velocity, being a vector, is dependent on both speed and direction. Take this heavy cart, for example. The cart is aligned on top of tracks. The mass of the cart is so great, and the force of friction between the four wheels of the carts is so small, that when the cart is pushed and then released, it will maintain a constant velocity and no longer accelerate. First, let's look at one situation. If two objects are moving parallel with a constant velocity, can you tell if the other is moving? Not without a reference frame. Here, you cannot tell if the cart is moving or still because there is no reference frame. If you change the perspective to one that is stationary, it is clear that if the cart is moving or is stationary, as you can see the cart getting closer to the camera. In this scenario, the background is the reference frame, which gives the different positions of the cart various depths. The second case presented is that the laws of physics remain the same for all inertial frames. If you were standing over a red strip of tape on a plane traveling 700 miles per hour, you could jump straight up with respect to the red strip, the same way you would be able to do so on the ground. This can be seen if we take the cart in the previous example and launch a projectile vertically upward. When looked at from a point of view moving at the same velocity as the cannon and cart, it cannot be determined if the objects being observed are in motion or at rest. The projectile appears to shoot straight up from the cannon in both videos. If the point of view changes, as before, it is clearly seen that the projectile does fire straight up from the cannon in the first case, while the cart is at rest. From the same point of view, when the cart is moving, it is clear that the projectile in fact travels both horizontally and vertically. With respect to the cart, the projectile behaves the same way stationary or moving with a constant velocity. With respect to the track or a different frame, the projectile only moves vertically when the cart is stationary, and moves both vertically and horizontally when the cart moves with constant velocity. These trials confirm Galileo's statement. Any two observers moving at constant speed and direction with respect to one another will obtain the same results for all mechanical experiments.